Hello there, how's it going? Mr. Sutton bringing you the IM374 Part 2 homework solutions on applications of right triangle trigonometry. For this delightful problem, we're 50 feet up in a tree hanging out, and the angle of depression from you to a rabid polar bear is 44 degrees. How long will a slide have to be for the bear to run up and eat you? Well, angle of depression, we're dealing with an upside down right triangle. Here's you up in the tree, here's the bear down here, and the hypotenuse is the theoretical slide the bear could run up to consume you. So we're 50 feet up in this tree. That's this distance down here from you to the floor. But there's no part of the triangle over there, so we'll use this height of the triangle instead to represent that 50 feet. And then the angle of depression is 44 degrees. That's the angle between the horizontal and the hypotenuse, this angle right here. How long will the slide have to be? Well, we said the slide was the hypotenuse, so that's a distance of x feet. And to figure that out, let's see what sides of the triangle we're dealing with. The 50 feet, that's across from the angle, so that's the opposite side. X is the hypotenuse. Opposite hypotenuse, that's the so part of SOHCAHTOA. So we're using sine of theta equals opposite over hypotenuse. So we can write sine of 44 equals opposite side of 50 over hypotenuse of x. Now to solve for x, we have to multiply by x and divide by sine of 44. So basically swap these to get x equals 50 over sine of 44. And now we have to plug that in the calculator. So plugging in 50 over sine of 44 in degrees mode, that comes out to 71.9 and some change. So actually 72.0 if we round it off to the nearest tenth. And that is going to be in feet. So on this problem, apparently I made it into the problem. According to whoever wrote this, I am 69 inches. That's actually a fact. I am 5'9", at least at the time of this voicing. I think I shrink a little bit every year. The ant I'm about to accidentally squish is 36 inches away on the ground. I would never intentionally step on an ant. What is the angle of elevation from the ant to Mr. Sutton? All right, so since we have an angle of elevation, that is a right side up triangle. And let's see here. Here's the ant. Here is me. Apparently this is angle of elevation to my head, I would think, to the top of me. So we've got 69 inches that I am, so that's going to be this side of the triangle, 69 inches. And this ant is 36 inches away on the ground, so that's this side of the triangle down here, so 36 inches down there. We want the angle of elevation. That's this angle between the horizontal and the hypotenuse. And so now to find that, let's see what side of the triangle I have. So that tells me which flavor of SOHCAHTOA I need to use. So I've got the side across from the angle, that's the opposite side, and also the non-hypotenuse leg of the angle, which is the adjacent side. So that is going to be, let's see, opposite, adjacent, that's the TOA part of SOHCAHTOA. So we use tangent. Tan of theta equals opposite over adjacent. So in this case, we have tan of the angle we're looking for, x, equaling that opposite side of 69 over the adjacent side 36. To actually get the angle, I have to do inverse tan of 69 over 36. And for that, I need the calculator. So here we are on my calculator. I did second tan to get tan inverse, and then 69 over 36, enter. That gives me 62.4 degrees for that angle of elevation. For this problem, when the sun is 40 degrees above the horizon, how long is the shadow cast by a tree that's 55 feet tall? This one's a little bit tricky to visualize, but at the very least, we're talking about 40 degrees above the horizon. So if you at least know you're talking about angles of elevation and depression, this is an elevation kind of angle. So let's use a right side up triangle just to kind of get our bearings on this one. So now 40 degrees above, so that's this angle here between the horizontal and the hypotenuse. That's our angle of elevation. In terms of what else is going on here, we have a tree that's over here. That's this right side of the triangle. And the sun is somewhere over here off to the right, casting a shadow from this tree. And here's the shadow on the ground. So this vertical distance is the height of the tree. This horizontal distance is actually the distance of the shadow. So they say that the tree is 55 feet tall, so that's the height of the triangle here is 55 feet. They want to know how long is the shadow, so that is going to be down here. Okay, so let's go ahead and solve for x at this point. Now in terms of sides of the triangle, we have the side across from the angle, that's the opposite side. we're looking for the non-hypotenuse leg that's touching the angle, so that's the adjacent side. Opposite, adjacent, we're talking the TOA part of SOHCAHTOA. So we can say tan of theta equals opposite over adjacent. So in this case, we have tan of 40 degrees equaling our opposite side of 55 over the adjacent side of x. And now to solve for x, I have to multiply by x and then immediately divide by tan of 40. So that's 55 over 40 that we're going to be doing, or 55 over tan of 40 that we're doing on the calculator. So plugging that in, let's see how long that shadow is. Approximately 65.5, and that's going to be in feet. On this one, an architect is designing a new parking garage for the city. The floors of the parking garage are going to be 10 feet apart, and the exit ramps between the floors are going to be 75 feet long. What's the angle of elevation of each ramp? Well, angle of elevation, we're talking about a right side up triangle. Now, they said the floors of the parking garage are 10 feet apart. So this hypotenuse here is your ramp. The bottom here this is your bottom floor. Up here at the top of the triangle is the next floor up. So if they're 10 feet apart, that's a vertical distance of 10 feet. And now they said the exit ramps themselves are 75 feet. So that's the length of this hypotenuse here. And they want the angle of elevation. So that's this angle down here between the horizontal and the hypotenuse. So to get that, we notice that we have the side across from the angle. That's the opposite side. We also have the hypotenuse. Opposite and hypotenuse, we're talking about the SO part of SOHCAHTOA. So that's sine of theta equals opposite over hypotenuse. So we can write sine of x in this case equals the opposite side 10 over the hypotenuse of 75. Now to get the angle, I have to do sine inverse of 10 over 75. And let's see what that is on the calculator. So plugging that in the calculator, we end up with about 7.7, and that's going to be in degrees. For this problem, we have a 50-yard tall vertical tower braced with a cable secured at the top of the tower. We want a person's angle of depression to the wire anchor from the top of the tower if the anchor is 65 feet from the base of the tower. Okay, so we've got an angle of depression. If you're having trouble visualizing this one, at least start with angle of depression. That means we have an upside-down triangle. So here is the tower's top up here, and then we have a cable coming down to an anchor that's on the ground down here. That's what's going on visually. So let's put some dimensions on this. So we have a 50-yard vertical tower. So first off, here's the tower over here on the left. We're not even drawing it, but you could draw a tower in if you wanted. That's 50 yards tall. Now, that's not part of the triangle, but we have this height of the triangle that's the same height as this tower over here. So we're going to put that 50 yards over here on this side of the triangle. Before we write down 50, though, we got to make sure that we're using consistent units, because they also talk about this wire anchor being 65 feet from the base of the tower. So we've got yards for one set of units and feet for another. Clearly, we can't just write 55 and 50 and 65 and hope that this is going to work out correctly. So we either have to convert yards to feet or convert feet to yards. I think it's going to be easier to convert yards to feet because to convert to feet, you just have to multiply yards by 3. If we're converting from feet to yards, you have to divide by 3, and that's not going to divide evenly. So this 50 yards over here for the height, I'm going to call that 3 times 50 feet, so 150 feet. Now, they also said that the wire anchor is 65 feet from the base of the tower. So here's the base of the tower over here in the lower left. Here's the anchor. So this distance is 65 feet, but again, that's not part of the triangle, so we use the top of the triangle that represents the same distance and put the 65 feet up there. Now we wanted the angle of depression. That is the angle between the horizontal of the triangle and the hypotenuse, so this angle right in here. Now to get that, just thinking in terms of SOHCAHTOA, we've got the side across from the angle, that's the opposite side, and 65 is the adjacent side. It's the non-hypotenuse leg of the angle. So opposite, adjacent, we're talking TOA from SOHCAHTOA, so that's tan equals opposite over adjacent. So we can write tan of x equals my opposite side of 150 divided by my adjacent side of 65. And now to get the actual angle x, I have to do inverse tan of 150 over 65. And let's see what that is on the calculator. So doing second tan on the calculator and putting in 150 over 65, I get approximately 66.6 degrees for this one. On this problem, we have Richard flying a kite, and the string makes an angle of 57 degrees with the ground. So Richard's standing 100 feet from a point on the ground directly below the kite. We want the length of the string. Well, this is 57 degrees with the ground. This is an angle of elevation to the kite. So this is a right side up triangle we can use, and our angle of elevation is going to be between the horizontal and the hypotenuse, so 57 degrees right in there. Now we said that the Richard is standing 100 feet from the point on the ground directly below the kite. So here's Richard over here on the left. Here's the kite up here in this upper right corner, but here's the point on the ground that's directly below the kite. So we've got 100 feet between Richard and this point on the ground, so 100 down there. And if we want to know the length of the kite string, well, the kite string is this hypotenuse going from Richard to the kite. So that's going to be an x for that hypotenuse. Now to find that, using a little SOHCAHTOA here, we notice that we have that we're looking for the hypotenuse, and we have this side down here, which is touching the angle, but it's not the hypotenuse, so this is the adjacent side. If we have adjacent and hypotenuse in the problem, we're using CA from SOHCAHTOA, so that's cosine of theta equals adjacent over hypotenuse. So in this case, we have cosine of 57 degrees equaling the adjacent side of 100 over my hypotenuse of x. And then to actually get x, I have to multiply by x and divide by cosine of 57. So we have 100 over cosine of 57, and just plug that in the calculator. So doing 100 divided by cosine of 57, that gives us about 183.6, and that is going to be in feet. So that's how long that kite string is.